Hi, future doctors. Welcome to the next class. We were discussing in rotational dynamics vertical circular motion, and we discussed velocities at different points. So at A, what is the velocity? At B, what is the velocity? At C, at D. So already we discussed. And tensional force also at any point. Now we will see what is the velocity at any point. Let us assume this is the point P where object is going to be present. So always tangent gives the direction of velocity. So VA we got already. That is going to be root 5G R. Now sometimes they will give this value, otherwise VA only or some value or some equation V naught V like that they are going to give at bottommost point of vertical circular motion. Now, what is the velocity at that point? Whenever it is making an angle theta with vertical, they may give anything horizontal, vertical. At the time, simply we will follow again to find not only at A, B, C, D, at any point we will find by using law of conservation of energy. So total energy at A should be equal to total energy at point B. Now, which energy at A means sum of potential energy and kinetic energy. Potential energy is 0. So, kinetic energy is half m VA square. Next, here potential energy. How much height it is going to be rising. So, from A to B, height we said R. From A to C, height we said 2R. Now, from A to B, what is the height? This is the going to be height. How we are going to get that height means this R radius will not be changed. This one and this one is going to be same. This is R means. So, this one OA. So, this point you can take O dash. Now, what is O dash from the diagram? So, O dash is going to be R cos theta. If you see, this is going to be R cos theta. So, we want this height. So, what is OA? So, OA is going to be R. Now, from this, what is this height means? H is equal to R minus R cos theta. So, horizontally you are going to get R sin theta. Already this one we discussed in work energy power lesson. How much height simple pendulum is going to be raised? What is the work done to make an angle theta? MGL into or MGR into 1 minus cos theta. Same like this. Therefore, MGH. In place of this H, we can write R minus R cos theta plus half M velocity at point square. In place of which what we can write? So all m's you can cancel. So VA square by 2 is equal to G into R minus R cos theta plus velocity at point square by 2. So if you send, we want VP square, velocity at point square. You can send this one this side. So what you are going to get means VP square by 2 is equal to VA square by 2 minus G into R minus R cos theta. If you are taking LCM, velocity at point square by 2. So VA square minus 2G into R minus R cos theta by 2. So if you cancel this 2 and this 2, velocity at point square equal to VA square minus 2G. If you are taking R common, 1 minus cos theta. So, velocity at point is equal to root of VA square minus 2GR into 1 minus cos theta. So, like this you can remember velocity at any point. What is VA means? Velocity at bottommost point. So, this is going to be root 5GR. Correct? So, this is the velocity at any point. Sometimes this point they give here Q. What is the velocity at point Q? They will give at the time some angle it is going to make with this horizontal theta. At that time, you should take total angle, how much? 90 plus theta. How much height it is going to be raised? How much height it is going to be raised means here it is going to be r. If it is going to be theta, then this is going to be r cos theta. This is going to be what it is going to be r sin theta. How much height it is coming? So this is going to be r, this is going to be r sin theta. Therefore, total height is r plus r sin theta in this case. So like this, you can solve any problem just if you know the concept how to apply. So wherever you want to find velocity, we are applying blindly law of conservation of energy. Now we will see tensional force. What is the tensional force at A, bottommost point, topmost point, all this. Now see, in vertical circular motion, so at bottommost point, A, B, C, D. Now what is the tensional force at A? TA is going to be, already we have given formula for that. Tensional force at any point. What we give that formula? At any point P, TP is going to be mg cos theta plus m velocity at that point square by r. That is the tensional force at any point. Now TA, tensional force at A. So TA is going to be so mg cos 0. Therefore, mva square by r. So what is the velocity whenever it is going to be moving at this point means root 5gr. So substitute that value here, then you will get mg plus m by r. What is va square? 5gr. If you cancel r and r, you got 5mg plus mg. You got 6 mg. This is the tensional force at A. So at this point, TA is going to be 6 mg. Next, what is the tensional force at B? TB. TB is mg. What is theta here? 90. Therefore, this value is going to become 0. M VB square by R. Velocity at this point B. What is VB we got? 3gr. So m by r 3gr. VB is going to be root 3gr we got. Therefore, r will be cancelled. TB is equal to 3 mg. Next, already we got here TC is going to become 0. So, to move in circular path, what is the VC? Velocity at C is going to be root gr we got. Isn't it? Now, what is the tensional force difference between bottommost point and topmost point? They will ask. At the time, TA minus TC is going to be TA is 6 mg, TC is going to be 0. So, like this, we can calculate. So, somewhere they will give where theta is going to make 60 degrees. So, what is the tensional force at that point? At the time, we will apply mg cos 60 plus mv square by r at that point. Velocity at that point we have to take. Next, whenever it is at rest, if it is suspended by any object, what is the T tensional force? Tensional force should be equal to mg. Therefore, velocity at this point A, whenever it is at rest, it is 0 means then T is going to be equal to, you will get mg only. Understood? Next, this one, how to remember logically. So, without having this derivation, so how to apply logic, we will see very easily. So, this is vertical circular motion. So, at this point A, so they will give TA. So TA we got here 6 mg. Then what is VA we got? Root 5 gr. Okay. So this value n, they will give. Velocity at bottommost point is going to be root NGR. Then what is the tensional force at that point A? So if it is NGR means tensional force is going to be 6. 6 means N plus 1 mg. N plus 1 mg you are going to get. So like this you have to remember. Velocity at point B. VB is going to be, how much we got here? Root 3GR. Then what is TB? TB is going to be, where we wrote TB? So TB is going to be 3 mg. Therefore, VB, velocity at horizontal position, they gave NGR. Then TB is going to be NMG. Like that you have to remember. Even at topmost point also, you are going to get. How we will get means, so tensional force here, 0. So velocity at C, VC is going to be NGR. Here in place of N, how much is there? NGR means N value 1 here. Correct? 1 means TC became 1 minus 1. Therefore, tensional force at C is going to be N minus N mg. Correct? Because tensional force is going to become 0. N minus 1 mg if it is going to be 1 here. 1 minus 1 mg. There if it is NGR, so N minus N mg. Like that logically you have to remember. Let us assume in some question they have given for you at bottommost point velocity VA is going to be root 9 GR they gave. Let us assume. Root 9 GR they gave means what is the tensional force at A? So root 5GR they gave, tensional force is going to be 6 mg. Here root 9GR they gave. Therefore tensional force is going to be N plus 1 mg. TA is going to be 10 mg you have to write. So VA they will give indirectly 3 root GR at bottommost point. At the time, what is the tensional force at A? VA is going to be this 3 if you send the inside 9 GR. Again you got here in place of N 9, therefore tensional force at A is going to be N plus 1 mg. So 10 mg you will get, isn't it? So like this you have to remember logically. So if you apply logic you will get very easily. Otherwise you have to apply this law of conservation of energy at each and every point, then you are going to get the answer. So this is about tension at any point in vertical circular motion and velocity at any point also we give. If you forgot velocity, you have to apply law of conservation of energy fastly. Sometimes you cannot apply everywhere that formula directly. You have to do like this by applying law of conservation of energy, isn't it? So I hope you people understood. Now you can try some problems on vertical circular motion. Thank you.